One of the Atari STEs I recently acquired wouldn't turn on, but I could hear the power supply fan trying to kick in, then immediately stop, and doing it over and over. In this video, I'll guide you through my troubleshooting steps and explain how I fixed it. If you don't know what you're doing, don't attempt this. First, I tried to understand the behavior and managed to get a hold of the schematic. This is a switching power supply, as opposed to the older Atari generations that had those bulky external rectified output transformers. Advantages of switching power supplies is a better efficiency and the ability to have a feedback from the secondary or low voltage side to keep a constant voltage independently from the load. In this unit, the brain is this IC, the UC3844. My analysis of the schematic went as follows. When plugged, nothing is happening at the start, as the IC is not powered yet. The first step is to power that brain. To do so, we have those two very high resistances slowly charging this capacitor. It takes about a second or two for it to have enough voltage for the IC to start. Only then, the IC starts to feed the transistor with some high frequencies to feed the transformer. Now it's active. This requires more power than those two resistors can provide. So once we have the transformer fed, this part of the transformer provides enough juice for the IC to keep working. On the right side, we have the low voltage coils that are feeding the various rails, plus 12, plus 5, minus 12, minus 5, etc. Now, for the regulation, it's using a feedback loop. It's only monitoring the 5 volt rail on this power supply. That little component is an optoisolator, and will tell the brain if it needs to switch more or less depending on the load. Here's the thing. With the way this power supply is engineered, when there is no load, after a second, voltage on the 5 volt rail will be reached, and it will seem stable, so it will tell the brain, stop, don't provide more power. As a result, this section also stops generating power, and the brain's supply voltage will drop to a point where it's not enough for it to keep operating, and stops. Those threshold voltages are visible on the datasheet here. It kicks in at 16 volts and stops at 10 volts. And that's exactly what we're seeing on the scope. Slowly charges through the resistors until 16 volt, then stopping around 10 volts. In other words, when no load is applied, you will hear the fan cycling on and off forever due to a bad design that only monitors the 5 volt rail. This is the expected behavior. Now, the issue I had is that my unit was still doing the same when under load. That actually took me some time to figure it out, but this diode was the culprit. It was just not forwarding current, and the voltage ended up dropping below 10 volts, causing the same behavior, cycling on and off the same way it does when under no load. I can't explain why it failed. We usually expect capacitors to fail on those old units, but they all tested good. I also don't expect this to be common. I just hope this helps you understand my troubleshooting steps. Thanks for watching, and see you for the next project!